Okay, so a physics alert. So you download the list from the Feeboard, all right, and then get used to it because you are going to use the same list of constant and list of formula in the exam. So now let's go through questions one. Questions one, the symbols for the dimensions of mass, length, and times are m, l, and t respectively. What are the dimensions of power? So in exam, you need to know a bit of its, I would say, the formula in order to derive the dimensions. So we know P is equals to W over T, and P at the same time, it is equals to delta K uh, over T, or I would say use Fs is easier. Okay, W is equals to Fs cos theta, so Fs over T. Okay, so F, we have MA. So MA S over T. Now, I think this is a simple enough for us to derive the dimensions. So let's see. So dimensions for M, A, S, and also T. So which is equals to, now M is mass. Mass, the dimension is M. Accelerations, the dimension is LT negative 2. Okay, so this is dimensions for A. And the dimension for S, now S is a length, a types of length, therefore it is L. Divided by time, okay, the time, so we have a T here. Therefore, it is equals to ml square t negative 3. So the answer is C. Okay, the answer is C. So this is how you do a dimensional questions, right? So let's move to questions number 2. So questions number 2 is a graph questions. Now you see, answer questions 2 and 3 based on the figure below. So usually one figures you have 2, 3 questions. So figure shows a velocity time graph of emotions along a straight line. So now you have a V against T graph. Remember what I told you before? Whenever you have a graph questions, you need to know which part of the graph represent which quantity, which variables. So for V against T graph, okay, the gradients of the graph represents the acceleration. And then area under the graph represent distance. So these are the informations that we can get from a VT graph. Okay, from a VT graph. So questions 2. Calculate the average velocity of the entire motions. Well, if you remember what is the equations for average velocity, so V average is equals to S final minus S initial divided by T final minus T initial. So obviously, initially everything starts from 0. So your initial value is 0. Final value, now how to calculate final S? Well, final S is the S for whole journey. So basically you calculate the area. So area under the graph, okay, under VT graph, divided by the total times taken, which is 45 seconds. Then you will obtain the answer 10.17 meter per second. Now this area given is a trapezium shape. In case in the exam you don't know how to calculate the area for trapezium, okay, your brain suddenly short circuit. So what can you do? You can calculate the area of this triangle and then plus the area of this rectangle and plus the area for this triangle again. Okay, you can calculate the area, you can split into 3 different areas and then you just add them up. Also can. All right, that is nothing wrong. So total area under the graph divided by a 45 second, then you obtain the average velocity. So next question, okay, next question is tricky. Calculate the average accelerations. So you have to recall what is the equation for average acceleration. So it is equals to V final minus V initial divided by T final minus T initial. Now let's go back to the graph. Your T initial, your V initial, where is your V initial? Initial position is here, which is equals to 0 velocity. And the final position is here, which is also located at V equals to 0. So this is your V equals to 0. So final and initial, both of them, they are equals to 0. Therefore, 0 over 45 seconds, it is also equals to 0 ms negative 2. You don't even have to calculate if you understand the diagram. Okay, if you understand the diagram. So this is a questions number 3. Let's look at questions number 4. Questions number 4 is a very simple questions. Okay, so a car is capable of accelerating. So this is your positive A because it's accelerate. Calculate the times needed for the car to go from the speed of a 5.5 meter per second, this is your U, to a final speed, this is your V. Calculate the times. So you want the time. So which equations consist of U, A, V, T? These 4 variables. Well, apparently it's V equals to U plus AT. So V, we have it number 8, 5.5 plus positive A, and then T. Rearrange the equations. Eventually, you will obtain 4.17 second. Okay, 4.17 second. So when it comes to this Google Forms type questions, okay, the 1 point questions is a simple question, which I call it C3 questions. C3 questions, it needs just one equation. All right, you can solve it by just using one equations. And then questions 5 actually is a 2 point question. It should be C4 questions. Okay, so this is your C4 questions, which means it needs, okay, it involves more than, okay, equals to or more than, okay, equal or more than 2 equations to solve this one questions. All right, which is a C4 layer. It needs a bit of thinking. You need to think a bit in order to solve it. So how to solve these questions? Now you decide to flip the coin to determine whether to do your physics or English homework first. The coin is flipped straight up. So now you have a coin. This is the coin. Okay, you flip it. It reach a maximum height. Okay, at a 0.25 meter above where you release it, and then it drops, and you catch it at the same height as you release it. Okay, so I'm going to take here as h equals to 0. Okay, so this is when your h is equals to maximum. H is at maximum value, which is equals to 0.25 meter. Okay, and what is the information that you have? Now it tells you your object reaches a maximum height, which means v is equals to 0 at this position. Okay, v is equals to 0 at these positions. And then your u is at where you release it. And there are 2 possibilities. Okay, so you have either the initial u and the final v for the blue color, or you can take another possibility where this is your initial u and your final v is located at h equals to 0. So at this position, your v is actually equals to negative u. Okay, your v is equals to negative u. So you flip a coin, and then what is the other information that you have? Now this is a vertical motion. So we have A is equals to negative 9.81 ms negative 2. So there are 2 methods that can be used to solve these questions. I will go through both of them with you as a part of revision. So method 1, I'm going to use the informations in blue color. I'm going to take maximum height as my final position. Okay, now I'm going to take final position at maximum height. So this is my initial. Okay, initial is here, I, and then this is final, F. So initial positions, I have a u, which is an unknown value, so I don't have the enough information. What I do have right now is A equals to negative 9.81 ms negative 2. What I have right now is h equals to 0.25 meter. What I have right now is v equals to 0. Okay, h is also your s. Okay, so 0 ms negative 2. Now I want to determine the values of time. So do I have any information that consists of these 4 variables? Okay, let's see. So the 4 equations that we have in chapter 2 is v equals to u plus at, v square equals to u square plus 2as, s equals to ut plus 1 over 2 at square, and then s equals to 1 over 2 u plus vt. Well, it seems like I don't have equations that have a, s, v, and t together. So what I can do right now is I try to find u first. okay, I can determine u first based on the information that I have. So I can determine u by using the second equation. So v squared equals to u squared plus 2as. From here, I have 0 equals to u squared plus 2 negative 9.81 times positive s. All right, so from here, I obtain u, which is equals to, okay, wait, yeah, let me calculate. So physics alert, I don't have the answer scheme. So we are going to do it together. So if I make any mistake, remember to tell me. And then square root, oops. 2 times 9.81 times 0.25, square root the value. So the velocity is a 2.215 meter per second. Okay, I'm going to take a positive value because initially my object is going upwards. So when you square it, you have plus minus. So in this case, I'm using a positive value. So now that you have u, okay, and you have a, s, and v, basically you can use either one equations to calculate the time. Okay, so let's say I use the first equations. V equals to u plus at. So v is a 0, u is 2.215 plus a is a negative 9.81, and then times with the t. Rearrange equations, you will then obtain t is equals to 0.225 second. Why 0.225? But if you look at the answer, it tells you the answer is 0.45 second. Well, because if you use final positions at maximum height, then the total flight times, the total times in the air, okay, total time spent in the air, it should be 2t. Okay, the time taken from bottoms to reach maximum height, this is your 1t, okay, which is equals to 0.225 second. And then it takes another 0.225 second to reach the same height, okay, to reach the same h. So total times in the air, okay, total times in the air is equals to 2t, which is then equals to 0.45 second, right? So this is how you solve it. This is how you solve the questions, starting from calculate u. So this is a typical C4 questions, okay, where you need to apply two equations in order to obtain the final answer. And now let's look at method 2. So method 2, what am I going to do right now? Okay, I take the initial positions here, and here is my final position. So initial and final, both of them, they located at same height. So what I have right now, s equals to h equals to 0 meter. Okay, and then I have a equals to negative 9.81 ms negative 1. And then what else do I have? Okay, now I know that my v is equals to negative u. Okay, so this is the information that I have. And then, okay, and then what can I do right now? I don't have t. Okay, so what I can do, I can use the maximum height to determine the value of initial velocity first. Okay, so this step is slightly more complicated. So we first, okay, first step number 1 determines, okay, determine u by using info at maximum height. Okay, at maximum height. So what I have right now, okay, basically same as just now, okay, this part. So v square equals to u square plus 2as at maximum height. So it's 0 equals to u square plus 2 negative 9.81. S is your 0.25. So u is then equals to 2.215 ms negative 1. Now, the advantage of using the final positions at your h equals to 0 is now you don't have to times 2, the time. Okay, the times that you obtain by using s equals to 0, and then a equals to negative 9.81 ms negative 2, and u equals to 2.25 ms negative 1, it is straight away equals to your total times in the air. So s, a, u, and now I want to find t. So the equations that I can use obviously is S equals to UT plus 1 over 2AT squared. S is a 0, and then 2.25T plus 1 over 2 negative 9.81 T squared. Rearrange equation. Straight away, I obtain the total times in the air, which is T equals to 0.45 seconds. So this question is very good questions. These are very good questions for you to see what is the difference between maximum height and when the object goes back to the initial position. The same concept can also be applied in projectile motions, the y component of projectile motion. Okay, so this is exactly what happens in a projectile motions. You throw something, it reaches maximum height, and then it goes back to the ground. Okay, so this is what happens along the y components in a projectile motion. So this is a very good questions. I want you to copy down the method 1 and method 2, both method. So I give you 5 minutes to write it down before I proceed to next question. Alright. So soalan susah dalam Physics Alert tak banyak. Ini salah satu soalan yang susah. Okay, so I give you 5 minutes to write it down. Make sure to write down both method 1 and method 2. Okay. So questions 5, 2 method, I show you both because I want you to understand the difference between maximum height and also the same height, okay, the original height. So sometimes questions, you might need to use the blue color method to solve it. Sometimes you might need to use a green color method to solve it. So make sure you understand both of it. And it is up to you actually when it comes to this type of questions. You're the one that choose your final position. Okay, tak semestinya mesti ikut salah satu cara. Okay, kedua-dua kaedah betul, dia terpulang pada macam mana anda pilih. Okay, so let's move on to the next question. Questions 6 and 7, they are based on the figure below. So this figure itself, you can use it to answer 2 questions. So a gun is aimed and fired horizontally at the target P. Okay, so which is 30 meters away. So this 30 meter is actually your SX. The bullet accidentally hits point Q, which is 1.9 cm below the target as shown in the figure below. So this is your SY. So when it comes to projectile motions questions, it is always a good idea to make a table, okay, where we can keep all of the informations in a neat way. So this is your X, this is your Y, U, V, A, S, T. Okay, so now these types of a projectile motion, this is what we call horizontal projectile motions. Okay, horizontal projectile motions. So what is so special about this horizontal projectile motion? Well, it tells us initial velocity, your U, is equals to your UX and UY is equals to 0. This is the things that we must know in a horizontal projectile motion. So straight away, we can substitute UY equals to 0 in a table because initially there's no Y component. And V, we don't have the informations. How about A? Now, A for X component is always 0 because X component object is moving with constant velocity. And for Y component is always negative 9.81. It is moving with constant accelerations. So just a quick recall. X component, the assumption is object is moving with constant velocity. Y component object is moving with constant accelerations. So when it comes to constant accelerations, then we have the 4 linear equations. All right. When it comes to constant velocity, you have only one equation, which is xx equals to uxt. So let's complete the table. Do we have the S? Yes, we have Sx equals to 30 meter. Sy now. Sy, first of all, it is in terms of cm. Second thing, if you look at the diagram, this height is located below the original position. Therefore, it should be a negative value. Negative 1.9 times 10 to the power of negative 2 meter. All right, because you have a cm. So questions ask us to calculate time. So can you use x component? Obviously cannot because you don't have u. You have only one equations and now you don't have the informations about the initial velocity. Therefore, we are going to use y component. So let's see which equations can be used. Now we have a u, we have a, we have s. We want to find t. So obviously you have only one equation that can be used, which is s equals to ut plus 1 over 2at squared. So s is negative 1.9 times 10 to the power of negative 2 equals to u is 0 plus 1 over 2 negative 9.81 t squared. Rearrange the equations, we then obtain t is equals to 0.06 second. All right. So when it comes to objective questions, now these 4 answers actually they are very tricky. Why? Because I put 4 possibility in the answer. First one, if of course you get the right value. The second possibility is if you use positive s, you can still get the time. The third possibility, if you use 1.9 meter, you can also obtain the time in your calculation. Plus minus negative 1.9, you still have the answer here. All right. So it doesn't matter what types of mistake that you are doing, you can still get the answer. Ha ha ha. All right. So don't always trust yourself. Jangan tekan-tekan calculator dapat jawaban, oh, must be correct. No, you need to double check as well. All right. Because when it comes to objective questions, is the tricky part is all the possible mistake. Okay. We have already considered all the possible mistake when we make the answer. Okay. When we draft the answer. So it doesn't matter what types of careless mistake that you're doing. Either you forgot to insert the negative sign or either you forgot to change the unit. All of the possibility, you can still get the answer. Okay, so this questions memang is a very tricky questions. Okay, now the question 7, it wants you to calculate the speed, okay, when it emerged from the ground. So you want u, and we know at the same time u is equals to ux. Now that we have the time from previous question, so if you got the answer in question 6 wrong, then question 7 definitely is going to be wrong. All right, it cannot be correct. So now you have time equals to 0.06 second, and then as given is 30, so sx equals to uxt. Okay, Sx is 30 equals to 0.06 Ux. So Ux is then equals to 500 meter per second. So very simple. Okay, very simple. So I give you 2 minutes to write it down. This is a very typical type, a very simple projectile motions questions. Okay, so 2 minutes for you to write it down. Tak ada benda baru pun. Okay, just a quick revision. All right. Let's move on to the next questions. Okay, so we're done with the revisions for chapter 2. Now we're going to chapter 3. So chapter 3, answer questions 8 and 9 based on the figure below. So again, one figures can be used to answer 2 questions. Figure shows a ball of mass to 0.2 kg. So you have m equals to 0.2 kg. With a horizontal velocity 20 meter per second hits the wall. After 0.01 second, so time given that is in contact with the wall is 0.01 second, it rebounds with the same velocity. Okay, it rebounds with 20 meter per second. Calculate the impulse of the ball. Now, when it comes to this type of questions, usually students, they forgot about the sign. Okay, question tells you it's being rebounded with the same velocity, but now it's in the opposite direction. So the information that we have right now is actually m equals to 0.2 kg, t equals to 0.01 second. If you take initial velocity as positive direction, then your final velocity must be negative direction. All right, because it's being rebounded. So now you have all of the information how you need to calculate impulse. So J equals to delta P equals to mv minus mu. Plug in the value, you should obtain J equals to negative 8 kg ms negative 1. All right, so the answer is B. And then once you have it, calculate the average force. So now you want to calculate F. So how to calculate F? Since you have J, you have T. So we know J equals to Ft. Okay, J is negative 8. F times T 0.01 second. So F is actually equals to negative 800 Newton. Okay, so you have the answer in B. right? So this is just a very simple questions where you can straight away got the answer from one equations. Questions number 10. Okay, questions number 10. Two identical balls. Now, this is the part that I want you to take notes. The keyword is head-on. What does it mean by head-on? Head-on means they are coming from opposite direction. So now you have two identical balls. Okay, ball number 1 and ball number 2. So one is moving with speed. Let's say this one is moving with 4 meters per second. And ball 2 is coming from the opposite direction with 2 meters per second. So that is the meanings of head-on collision. All right. So, and then they stick together after they collide with each other. So calculate the speed after collisions. So what can we do? Now you have a collisions. Then we use conservations of momentum to calculate it. So summations P initial equals to summations P final. Initially, we have M1 U1 plus M2 U2 equals to, now it stick together. Therefore, M1 plus M2 times V. Well, because the questions also mentions identical ball. Okay, so why is it so important about the terms identical? It tells us M1 is equals to M2. Therefore, these equations can be rewritten in the form of MU plus MU1 plus MU2 equals to 2MV. Okay, so we don't have the mass of the ball, but what we can do right now is by cancelling out the M in the equations. You have M on the right hand side, you have M on the left hand side. So eventually you have equations U1 plus U2 equals to V. Okay, so V is equals to 1 meter per second. Okay, 1 meter per second. So this question is very simple. If you understand the meanings of head-on collision, if you understand what does it mean by identical, okay, identical ball, right? And remember, one of them, they should be negative. So if your U1, okay, your U1 should be positive 4, and then your U2 will be negative 2 meter per second because it's coming from the opposite direction. Oh, this is 2V, sorry. All right, so eventually you obtain V equals to 1 meter per second. Okay, 1 meter per second. So very simple. Okay, as long as you got the idea of what does it mean by identical, what does it mean by head-on collisions? Okay. Okay, next, questions 11. Okay, questions 11. A block of mass 2 kg is pushed along a horizontal surface with a force. Now, you see, this is a 2 marks questions, 2-point question. So means this question is slightly more complicated than previous questions. So you have a horizontal surface, a block on top of it. Now you push it with a force F equals to 3.2 Newton. And it experiences an acceleration A equals to 0.3 ms negative 2. What is the coefficient of friction? Now, based on this statement, it tells you you have a frictional force acting in the opposite direction. So this is a rough surface. All right, so the hidden meaning from the terms coefficient of friction means that this is actually a rough horizontal surface. And then when the object is moving, there is a force, okay, a frictional force that is trying to against it, against the motions. So now how are we going to solve these questions? First of all, well, let us sketch a free body diagram. So I have a force going to the right-hand side, a frictional force going in the opposite direction. This is an object. Every object comes with weight. And then you have a normal force because you place it on the surface. And then it has an acceleration that is going to the right, okay, which is equals to 0.3 meter per second. So you want to calculate coefficients of frictions means you are going to use the axis with frictional force. So I'm going to use summations Fx. Now, since my object is moving along the x component with an acceleration, therefore I will apply Newton's second law. So summations Fx equals to ma. I expand the equation so it becomes F minus F equals to ma. Well, I don't have the informations about the frictions. I don't have the values for friction and force. What I do have is I know F minus mu n because F frictional force is equals to mu n. Okay, so it is equals to MA. But then another questions arise. I don't have the values of a normal force. So what I need to do now, I need to think how to find out what is the value for n. So I can find the values of n by using vertical component, where summations Fy is equals to 0 because there's no motions along vertical component. So n is equals to W equals to mg. So from here, I can then calculate the values of n. Okay, so it's 2 kg times 9.81. So n is equals to 9.81 times 2. So 19.62. Okay, 19.62 Newton. So now that I have n, I can then plug in into the equations. Okay, so I have F, I have n, I have m, I have a. Rearrange the equations, I then obtain mu is equals to 0.13. So that is how you solve it. And that's why I call it a C4 questions. Why C4? Because you need an additional step, the step in blue color, before you can simplify, before you can get the final answer. Okay, so usually this is what we call C5 questions. You need to sub an equations into another equations and into another equations. Okay, from equations to equations. So this one, I give you 2 minutes to write it down. Okay, C4 questions, I give you the times to write it down. C3, I believe you can solve it. Okay, I just explain it, then you solve it by yourself. All right, so C4, you can write it down. 2 minutes for you to write down. All right. So done. Next, we're going to look at question 12. Question 12 is another 2 marks questions, okay, 2-point questions. Usually when it comes to force, it is a C4 type questions, all right, because if just give you C3 questions, then it will be too easy for you. Okay, so block A and block B of masses 3.5 kg and 2 kg respectively. So block A is 3.5 kg, block B is 2 kg. They are connected with a light string across a smooth pulley as shown in figure. At times t equals to 0 second, block A is being pulled by a force. So now you pull block A to the left-hand side, which means your acceleration should be going to the left. So for block B, acceleration should be going up. Okay, it's unlike the questions that we have been doing in a tutorial where you let the B drops and it will push block A to the right-hand side. No, now this is opposite situations. You pull block A and block B both move at the same time. Okay, so the coefficients of kinetic frictions between block A and the table. So now based on this statement, it tells you this is actually a rough surface. So there's a frictional force that is going towards opposite direction. Calculate the accelerations of both blocks. So when it comes to this type of questions, always sketch a free body diagram first. So I'm going to sketch a free body diagram for block A. So this is my block A. Now I pull it at an angle 30 degrees above horizontal. So this is the F. And then I have a frictional force. And at the same time, it is being connected by a string. So I have a tension going to the right-hand side as well. This block is being placed on the surface, therefore it has a normal force. I'm going to call it N. And then every object come with weight. So this is WA. Okay, you need a subscript here because now you have two object. You have two W. So for block B, okay, oh, and the directions of acceleration is going to the left. So for block B, it's very simple. Now you have a hanging object. So WB going down, and then T is going up. So your A is going up, right? So how are we going to solve it? Now it wants the accelerations. So accelerations exist in both situations, and in both situations we have unknown T. Okay, we don't have the values of T. So what we can do is we form equations. All right, let's form equations for object A first. So for object A, I have two dimensions. So summations fx is equals to ma. Okay, why ma? Because along the x component, my object is moving with accelerations. So what I need to do, I need to resolve f into two components. So this is my fx, and this is my fy in calculations. So for x component, I have two forces along the three forces along the x component. So what am I going to do? Fx minus t minus f equals to MAA. So this is the first equations that I obtained from block A. Okay, from block A. The second equations, okay, the second equation is summations Fy equals to 0 because there's no motions along the vertical component. So based on the free body diagram, what do I have? I have n plus Fy minus Wa equals to 0. So this is the second equations. Okay, so for block B, I don't have x components. Straight away, I'm going to use summations Fy for B. But if you look at summations Fy for B, okay, now you have only the motions along vertical component. Therefore, for block B, summations Fy is MBA. Okay, so expand the equations. Now I have T minus WB equals to MBA. So this is my third equations. Okay, my third equations. So basically, you just play around with these three equations. Okay, why play around with these three equations? First of all, because equations 1 and 3, they have two unknown T and unknown A. And then there's one more unknowns that we don't have, which is F. Okay, we don't have the values of F. But then we know that F can be calculated by using N. From here, we need to use a Y component from block A. Okay, because of the situations, because of the relationship, F equals to mu N. Okay, that's why we need these two equations, equations 1 and 2. So equations 2 is for you to find the frictional force. Once you have frictional force, you solve equations 1 and equations 3 simultaneous, and you should obtain A is equal to 0.45 ms negative 2. All right, 0.45 ms negative 2. So this is the final answer. All right, so I'm not going to show you step by step because we have been trying it. We have been doing this type of questions quite a lot of times already. Okay, so I give you 2 minutes to write down the step, and then after the class, you can try to solve it by yourself. Okay, so 2 minit bagi Anda catat semua maklumat ada dalam diagram. The information that you need is in the diagrams already. So you have the coefficients of friction, mu is equals to 0.20. So you try to solve it after class. Now you just write down the method. Okay, I showed you the method. So you yourself complete the solution. So 2 minutes for you to write it down. So boleh. So kita buat step by step. So done with questions 12. Now let's look at the questions 13. Questions 13, okay, there is a correction. So actually this is a bonus mark questions. So everyone still got a 2 marks bonus mark in your physics alert. So questions 13, the answer should be, wait, yeah, let me check. The correct answers is 588.61 joule. All right. So this question actually is a bit tricky. Why? Because if you didn't read until the end of the questions, then you will get the wrong answer. A man pulls a block, a 45 kg block at a constant speed on a rough surface as shown in the figure below. Now, if your object is moved at a constant speed, then the total work done is 0. In that case, that is correct. Because you have a constant speed means the A is 0. A is 0 means net force is 0. Net force 0, no work is done, okay? W is equal to 0. But now if you read until the end of the questions, it tells you the angle between the rope and the horizontal surface is 30 degrees, and the coefficients of kinetic frictions between the block and the surface is 0.6. One against it mentions coefficients of friction, means there is a frictional force. All right, between the block is 0.6. Calculate the work done by the rope. So if you read the questions until the end, then you should know that the answer shouldn't be equals to 0. All right, it shouldn't be equals to 0. So what are we going to do against? Okay, because you want to calculate the work done by the rope, means you need the tensions in the rope. Okay, you need the values of T. So how to calculate the values of T? It needs a bit of information from chapter 4. So let's begin with a free body diagram. So you have a frictional force going to the left-hand side. This is an object comes with weight, and then it has a normal force that's going up. And again, it's being pulled by a string, so this is a tensions, and it is at a point that is 30 degrees above the horizontal axis, horizontal component. So A is going to the right-hand side. So now that I have everything, so I can then determine the values of T. Okay, so how to calculate T? So again, I need to use both X and Y component because I don't have frictions, but then what I do know is F equals to mu N. So you see these equations actually it comes out very often in your exam, okay, in your past year question. So this is actually one of the past year questions. So F equals to mu N, and then we need N to determine friction. From frictions, we can then determine the tension. Okay, let us begin. So summations Fx is equals to ma. So x components has motion, so it's equals to ma. But now because your object is moving with constant velocity, therefore summations Fx is equals to 0. Why? Because a is equals to 0 at constant v. Okay, constant velocity. So we can then expand the equation. Before we expand the equations, remember to resolve your t. So you have a tx and ty. Okay, so tx minus f equals to 0. Tx is equals to your f. This is your first equations. Then let's move on to the second equation. Second equation, summations fy is equals to 0. Then what do we have? We have n plus ty minus w equals to 0. This is our second equations. So from these two equations, you can then simplify it and determine the values of t. All right. And once you have t, you can then calculate the work done by the rope. So we know in general, W is equals to F dot S based on the definition, which is Fs cos theta. Now you want to calculate work done by the rope. So WT is equals to Ts cos. Now theta is the angle between T and the directions of motion. So you're moving to the right hand side. Therefore, the angle between them is 30 degrees. So from here, you can then obtain the answer, which is 588.61 joule. All right. So this is the answer for questions number 13. So again, I give you 2 minutes to write down the step, the solutions. Okay, you yourself complete it with all of the values from the questions. Alright, so 2 minit bagi Anda salin dia punya step.
Madam,
Yap.
yang T tu ambil kat mana?
Ha, apa maksud yang T tu ambil kat mana?
T yang TS tu.
Kan saya dah tunjuk dekat sini, daripada equations 1 dengan equations 2, kamu kira sendiri.
Oh, okay.
Okay, so dapat kira, baru kamu masukkan ke dalam equations work done. Okay, next. So what are we going to do next? Questions 14. So questions 14 is just a very, very simple question. So we are done with all the hard questions in your physics alert. Okay, so the hard question is just until step number 13, questions number 13. The remaining questions, they are all very simple. So 14 figure shows the variations between the applied force and the compressions of a spring. So now you have a F against X graph, okay, or S. So when you have a Fs graph, so you want to find out what is the work done on the spring. So W equals to area under Fs graph. All right, area under Fs graph. So calculate the area until 0.2 meter from here to here. So you calculate the area, then eventually you will obtain work done is equals to 0.80 joule. Okay, 0.80 joule. So that is the work done. All right, and the next questions. Again, next question, you need to answer 2 questions based on the diagrams given. Answer questions 15 and 16 based on the figure below. Okay, so based on the figure below, we have a figure like this. A sphere of mass 4 kg that is initially at rest. So your initial velocity is equals to 0 ms negative 1. From here, we then know that K is equals to 0 joule because the object is at rest. So it slides along a smooth and curvy surface as shown in figure. Calculate the potential energy at point A. Well, potential energy is just U equals to mgh. So straight away plug in the value, then you will obtain 1569.6 joule. So this is a very simple questions. All right, mass is 4 kg given. So G is 9.81, and then you have a height given 40 meter. So straight away you can obtain the gravitational potential energy. Question 16. Calculate the speed of the sphere at point B. Now let's look at the diagram. point B is not located at the highest point nor the lowest point, which means at point B, okay, the potential energy is a non-zero value and the kinetic energy is also a non-zero value. All right, so what we can do to find out the values of a speed at location point B by using conservations of energy. So summations E initial equals to summations E final. U initial plus K initial equals to U final plus K final. So K initial, well, according to the diagram just now, we know is equals to 0 because velocity is equals to 0. All right. And then U initial from questions 15, you have the value already. So 1569.6 is actually equals to your mgh, the final height, which is 20 meter, plus 1 over 2 mv squared. So rearrange equations, you will then obtain v is equals to 19.81 ms negative 1. Okay, so again, this is a very simple question as long as you know what is the conservations of energy. Okay, what is the equations of conservations of energy. So tengok satu physics alert, kita dah revise, dapat revision untuk 5 chapter. Okay, so for this physics alert, actually we try to put in the questions from every single subtopic. That's why you have the numbers of questions, which is a very weird number, 17 questions in the test. Okay, because we try to cover every single subtopic in your syllabus. So it's a very good revisions actually. If you know how to answer all of them, okay, so which means your basic in chapter 1 until chapter 5 is already good enough. So you just need to work a bit harder, maybe to finish off the past year questions, then you can go for the exam already. Okay, so yeah, a very high chance for you to get A if you can score this very well and you can do past year questions. So question 17, a motorcycle overtakes a slow moving lorry by speeding up from 16 meter per second to 18 meter per second in 2 seconds. So you have U equals to 16 meter per second, V equals to 18 meter per second. And then the time T is equals to 2 seconds. And then it tells you the motorcycles and the rider, when you add them up, they are equals to 150 kg. So how to calculate the power? So this is a 2-point question. 2-point question means it's slightly harder. So now you want to calculate the required power. So we know P is equals to W over T according to the definitions. So by using work energy theorem, P is equals to delta K over T. Okay, so W, we have 2 choice. So the one that I use for derivations of dimensions, I use the definitions W equals to F dot S. Okay, and if you use work energy theorem, then W equals to delta K. In these questions, I use W equals to delta K because I'm given the velocity. So W equals to delta K. So we have P equals to delta K over T. So delta K, what does it mean? It means K final minus K initial over T. So therefore, P is equals to 1 over 2 mv square minus 1 over 2 mu square over T. So you see, I sub equations into equation. So this is what I call C4 type questions. Okay. So you plug the value into the equations, then you should obtain P is equals to 2.6 times 10 to the power of 3 watt. So that's why the answer is C, 2.6 kilowatt. All right. So that marks the end of physics alert. So I've done discussing all 17 questions with you. So basically means we are done with a revision from 1 until 5. Next lesson, which is the lessons on a Friday, I will discuss chapter 8 with you guys. All right. So if no questions and once you write it down, then you may leave the class. That's all for today. Okay. So catat. Kalau